To probe the unknown is the nature of modern biomedical research. And often along the way, we encounter the unexpected. But the unexpected can take a variety of forms, some of them less than welcome. This accident has been recreated to make a point. Working in a biomedical research lab is surely safer than the daily commute, but accidents do happen. The goal is to do the science, but at the same time, reduce the risk. What you might call practicing safe science. The laboratories of the Howard Hughes Medical Institute are to be found at institutions all over the country. Here at Cold Spring Harbor Laboratory, where biology has been pursued for nearly a century, is an apt place to draw some fresh conclusions about laboratory safety.
PK2, and it lines up precisely
with the pressures and competitive challenges of science today, do molecular biologists like David Beach still find time to be concerned about safety?
One of the main problems we have in the lab is actually knowing what the risks are. Covering yourself with phenol is a clear, simple risk, and the consequences are acute and dramatic. What we live with day by day is, in many ways, much more difficult. Is it more dangerous to dip your fingers into a gel box that contains ethidium bromide, or to mouth pipette some gamma-labeled P32, which nobody does? Which of those two is more dangerous? Or is it more dangerous to go and smoke a cigarette, or to get in your car and go home in the evening? I don't know which of those is the most dangerous. And that's in a way very frustrating. So the main problem I see is that we don't know what the real risks of each individual activity is. So we tend to act cautiously.
Although the risks of any given activity may be unknown, we clearly know the specific hazards. Or do we? How about looking at several everyday laboratory procedures and spotlighting them? In the first protocol, Arshad is preparing to equilibrate phenol. By the way, some questions, challenge questions, are going to pop up every now and then. Like this. Phenol poisoning can occur through which of these routes of exposure? Phenol is rapidly absorbed through the skin, and this route of exposure can cause poisoning as readily as inhalation. The fume hood, a great blessing, yet a source of distress for many a safety director. Here's one reason why. A vapor source placed in the hood lets us see what's actually happening. And if you take the trouble to pull the sash down to the marked level the way you're supposed to, yes, that's why you're supposed to pull the sash down. It does make a difference. Still, it's no guarantee. If something causes an air disturbance in the room, somebody walking past, or somebody closing the door on the way out to lunch, yes, even putting your own hands into the hood or taking them out can set up an eddy current. And of course, it doesn't require a red line to remind you that your work should be at least 4 to 6 inches inside the face of the cabinet.
One of my students was using radioactive iodide, and he was using it to iodinate a protein. So you tag a protein with a radioactive iodine. During this process, he obviously became contaminated. And tracing back now, what the problem was, how that arose, was found that hood was defective. So whereas we all thought that the radioactivity was being exhausted and diluted in the outside air, that was not occurring. I think this points to the importance when you're doing experiments that carry this kind of potential risk, to be sure that the equipment you're using is really functioning well. I think that's one of the lessons we certainly learned from that.
A search through the records of laboratory accidents came up with some eye-openers. Like this. Warm glass on a cold counter. A weakened seam at the base of the jar. A trickle of phenol. But phenol acts as a local anesthetic, delaying an awareness of the harm it's doing.
She first noticed it on her feet because she was wearing these open shoes, and it splashed onto the top of her feet, and she sort of started to yell as it began to burn into the top of her feet. What she hadn't realized, however, was that she'd actually poured it all down the front of her jeans, and it hadn't actually soaked through yet. After another 10 or 15 seconds, though, it began to soak through and contacted the skin of her legs, of her thighs. She developed quite severe burns that put her in the hospital for 3 or 4 days.
By far the worst I've seen were 2 accidents, and they both involved phenol. One was somebody trying to distill phenol, and the distillation apparatus blew up all over him, covering him with hot phenol. And the other was somebody doing a simple phenol chloroform extraction and having the lid pop off a tube and phenol distribute all over the person's arm. Both of those were very unpleasant.
Now in the lab, you know, there's nothing quite like seeing an accident for yourself. I mean, this happened in full view of everybody in the lab. It was really a horrifying thing to see. And now, anytime anyone handles phenol in this quantity, the lab coat is the first thing they put on.
What should be the first action in response to a phenol spill or splash on the skin? Flush immediately in a sink or safety shower and remove the clothes there. And never use ethanol. It can enhance absorption and dispersion.
I don't think one should look upon safety or the kinds of things you learn to do in order to reduce risk as being onerous. It's really it's part and parcel of doing your experiments. You learn to do it to do things in a certain way and to keep the risks low. I had one bad experience as an undergraduate. I was a chemistry major, and I was carrying out what's called a Kjeldahl reaction for measuring nitrogen content of a sample. And I did a very foolish thing. I poured concentrated acid into concentrated base solution that was hot. And what happened was absolutely predictable, but I wasn't thinking very clearly, and that is, it bubbled over right into my face.
The trick to having experiments work, particularly in molecular biology, at least in my experience, is concentration. Thinking exactly what you have to do, what you must do, and having it done the most effective way. And I think having to think about doing it in a safe way really helps one concentrate.